In the previous video we watched, we were introduced to probability trees. They were nice and helped us solve this game. 5 marbles are placed in a bag, 2 red marbles and 3 blue marbles. The contestant will select 1 marble from the bag and without replacing it will choose another marble again. If both marbles selected are red, the person will win a prize. And the tree we came up with looked like this. 5 branches for the first choice of marble, 2 red and 3 blue. But since we're not replacing that marble, now there are only 4 branches left for each second choice, and that looked like this. But what if I told you we could make this a bit easier and do an alternate version of a probability tree? Both of these will be correct, by the way, but many of you will find this second version much easier. Here's what I mean. What if we decided to look at it like this? For the first choice of marble, we can either get a red or a blue. That's it. There's no green, no yellow, just red or blue. And the probability of getting a red on the first choice is 2 out of 5. And that's because out of the 5 marbles to choose from, there are only 2 red ones. So 2 out of 5. And we can put that right here on the branch. And then, for the other branch, the probability of choosing a blue marble, well, it must be 3 out of 5, isn't it? 5 possible marbles, but only 3 of them blue. Good, and we are done our first row. Then, for our second branch of choices, just like the original probability tree we did, we just figured out the possible paths for each previous choice. So, for instance, if we got a red marble first, then for our second marble choice, we could still get either a red or a blue, couldn't we? There is still 1 red marble left, so red is possible. And there are 3 blue marbles left, so obviously blue is possible as well. Red or blue, those are the 2 branches that could happen. And now, all we have to do is write down the probabilities for those. Since there are 4 marbles left, with only 1 of them being a red one, that means there is a 1 out of 4 probability of selecting a red marble second. And with 3 out of the 4 marbles being blue, that's a probability of 3 out of 4. Nice! We are almost done our probability tree. Why don't you finish off the bottom half of the tree? You can do it. Just pause the video, and when you think you've got it, you can resume to see how you did. Have fun! Okay, here's the second half. See how you did. Now, how does it work? That is, how do we use this to calculate probabilities? Well, if you wanted to figure out the probability of any one branch happening, like say a blue marble first and then a red marble second, then you would just multiply the probabilities along that branch. For instance, we want to know the probability of getting 2 red marbles. So that would be this branch here. And the probability of that happening is going to be 2 out of 5 times 1 out of 4. To figure that out, when multiplying fractions, we multiply the numerators, or 2 times 1 in this case, which is 2, and we multiply the denominators, or 5 times 4, which is 20. And so, our probability is 2 out of 20, which we can reduce to 1 out of 10, or 10%. And if you remember, that is exactly what we calculated using the original probability tree. So both methods are correct, but many students find this way a lot easier. Both will work though, so either way, it's up to you.